Hi everyone, today we're going to be looking at the PLC program sequence for efficient robot loading operations. The integration of an automation and robotics has revolutionized modern industrial processes, particularly in material handling. The EasyPLC Machine Simulator Robot Loader, which loads boxes onto skids in manufacturing facilities, can be used to help learn PLC programming. This 3D simulation robot loader communicates with a Click PLC through Modbus TCP or Ethernet communication, enabling seamless coordination and control. The Click PLC utilizes a drum instruction to execute sequence control, ensuring optimal performance and precision. To ensure a successful implementation of the EasyPLC Robot Loader, we will follow the 5 essential steps of PLC program development. This comprehensive approach will guide you in creating a seamless operation that maximizes efficiency and productivity. So let's dive in and explore the exciting possibilities of how to program the EasyPLC Robot Loader. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. Step 1. Define the task. The initial phase of developing a PLC program involves defining the task at hand and determining the necessary steps to accomplish it. The EasyPLC software suite offers a variety of machine simulators, including a robot loading example, to aid in the learning and development of PLC programming skills. To access the EasyPLC Machine Simulator, or MS, simply navigate to the main page and select the Start button or choose Machines from the top menu within the simulator window. With this powerful tool at your disposal, you can confidently tackle any PLC programming challenge that comes your way. All of the available machines will now be displayed. Click on the Robot Loader. This is the example we will be programming. To the left of the screen, information will be displayed on how this process needs to function. Use the robot to load wood pallets with carton boxes. Each pallet must be loaded with 4 boxes. Manage the conveyors to feed pallets and boxes to the machine. Use the pallet stops to correctly allow the robot to load boxes onto the pallet. The machine simulator has a demo mode for the built-in machines. This will allow you to watch the operation of the robot loader machine. Select the demo mode. The EasyPLC demo mode on the machine simulator will operate, showing you the basics of operation. Move around this 3D virtual environment. The icons on the top of the window will allow you to move around this 3D environment. The first icon is the default selection. This will enable you to move around without bumping into any components. The first person mode will mimic a person in your 3D learning world. Third person is used to show the relationship of the operator to the machine. The last icon will automatically show you around this virtual environment. Once we understand what must be done, we can move on to the next step in our PLC program development. Step 2. Define the inputs and outputs. The View I/O at the bottom of the machine simulator window will display the inputs and outputs required for this robot loader example. While still in demo mode, you can see the operation of the inputs and outputs. The EasyPLC Robot Loader example will require 5 digital outputs and 5 digital inputs. Select the analog inputs and outputs. 6 analog outputs will control the robot position, and 6 analog inputs will indicate the current position of the robot, or feedback. Make a note of each of the positions that we will require for the robot movement. The EasyPLC Start mode will allow you to manually control the robot loader. Exit the demo mode and enter the Start mode for this machine. The Start mode is ideal if you need clarification on what an output or input is doing. Select the View I/O at the bottom middle of the machine simulator window. You can manually run the machine simulator without any control or PLC connection. You can now select the robot loader feed digital outputs on the left side of the screen by clicking on them with the mouse. The right side will show you the corresponding digital inputs. Select the analog inputs and outputs. Change the values to ensure that you know how the robot and feedback positions work. The restart button on the bottom of the machine simulator window will reset the machine back to the start. Move around this 3D environment and ensure you know what each input and output represents. Step 3. Develop a logical sequence of operation. A PLC programmer must know everything about the sequence and operation of the machine before programming. This robot loader example is an excellent way to learn to program. Flowcharts or sequence tables can help to understand the process that needs to be controlled thoroughly. It must also answer questions like the following. What happens when electrical power or pneumatic air is lost? What happens when inputs and outputs devices fail? Do we need redundancy? This step is where you'll spend most of your time. Understanding everything about the operation will save you time. It will help you from continuously rewriting your PLC program logic. Knowing all these answers on how the system is to react is vital in the development of the PLC program. This does not have to be a formal document. You must have a method to account for every condition in the machine being programmed. The robot loader has 2 conveyors. The belt conveyor will contain boxes. It will operate when there is not photocell 2 signal. When the conveyor is on, it will automatically create another box. Photocell 2 will stop the conveyor from operating. The boxes will be created all the time while the robot loader is running. The roller conveyor contains the pallets. When it is running, new pallets are created automatically. Conveyor stopper 1 will activate to position the pallet to accept boxes. Stopper 2 is used to prevent further pallets into the stacking location. If photocell 1 is not seen, then stopper 1 will be activated and the roller conveyor will turn on. When the photocell sees the pallet, the conveyor will stop and stopper 2 will activate. Once the pallet has 4 boxes, stopper 1 will deactivate and the roller conveyor will start. This will allow the full pallet to exit the machine. Stopper 2 then deactivates and allows the next pallet to be loaded. Our machine has a robot that will have 5 positions for each box that is loaded onto the pallet. It will also have a home position that we used after a full pallet is complete. Position 1 is above the box on the belt conveyor. Position 2 is when the box will get picked up by the robot. Position 3 is the location above the pallet. Position 4 is the location the robot will move for each of the 4 boxes. And the final 5th position is the same position as position 3 above the pallet. The robot loader also has 2 light curtains. These are located on the entrance and exit of the pallet roller conveyor. If the light curtain is tripped while the robot is moving, this will stop all movement. A reset of the system will then need to take place to start the operation again. A PLC programmer must know everything about the sequence and operation of the machine before programming. Ensure that you know what must happen will help to clarify what is required in the PLC program. Ask questions or view existing documentation to ensure that you know the logical steps to the machine's operation. This may involve speaking with the manufacturer, operators, engineers, etc. Create your own sequence of operation based on the information above. Step 4. Develop the Click PLC program. Using the information from the previous steps, we can now program our Click Plus PLC. The Click PLC series will take you through installing the program, communicating with the controller, providing instructions, and addressing the controller. Select COM port in the Setup tab on the main menu. The COM port setup window will allow you to select the different port setups on your Click PLC. Select Setup under Port 1. The COM port setup details window will now be displayed. Alternatively, you can get to this window by selecting COM port 1 setup under the Functions tab in the navigation window. You can see that we have manually set up the Ethernet port with the IP address for our network. Select the WLAN port. This is also set up manually for our network using Wi-Fi. Our PLC is a Modbus TCP server to the EasyPLC Modbus TCP client. Please make a note of the static IP addresses that we will be using for our Click PLC. This will be used later to connect the EasyPLC Machine Simulator or MS. We can now look at the ladder logic program of our Click PLC for our Robot Loader machine. We will also explain the logic as we look at the program. The drum instruction in the Click PLC has 6 steps and 6 outputs. Event input bits will determine the end of the step and continue with the next step. Outputs C1 to C6 will determine the sequence that we are currently running. C1 is loading the pallet. C2 is a robot to load box 1 onto pallet. C3 is robot to load box 2 onto the pallet. C4 is robot to load box 3 onto the pallet. C5 is robot to load box 4 onto the pallet. C6 is exit full pallet. This rung will control boxes. If photo cell 2 is not on, then activate conveyor belt to get another box. Step 1, load pallet, will set the conveyor stopper 1 and start the roller conveyor to bring in a pallet. When the pallet is seen by photo cell 1, then set conveyor stopper 2 and reset roller conveyor. C21 is the event to indicate that step 1 is complete and move on to step 2 in our drum sequence. The next step will call up the loading subroutine for each of the 4 boxes to load onto a conveyor. If the photo barrier or safety current is triggered on the entrance or exit of the roller conveyor and we are not on step 1 or 6, then the current position of the robot is then set into the set position of the robot. This will stop all movement of the robot. Rung 6 of the main ladder logic will control step 6 of the drum sequence. When step 6 is triggered, the conveyor stopper 1 will reset and the roller conveyor will start removing the full pallet of boxes. A timer is used to ensure that the pallet is out of the machine. When the conveyor 2 stopper is reset and then the signal for the end of the step is activated. This is the end of the main program. The subroutine logic is all similar except for box 4 loading. This will add an extra step to the robot to home before moving to step 6 and exiting the full pallet. Let's look at step 2, load box 1 onto the pallet. Once we enter step 2 and the pallet and box is in position, we will set the robot coordinates for the position 1. We then set a bit on to indicate that the step has been executed, C10. When in step 2 and the robot has been set for position 1, then compare the 6 axes to the current position to the set position. If they are the same, then set position 2 for the robot and set a bit C11 that indicates the robot movement. When in step 2 and the robot has been set for position 2, then compare the 6 axes of the current position to the set positions. If they are the same, then set the robot picker, set position 3, and set a bit C12 that indicates the robot movement to position 3. When in step 2, the robot has been set for position 3, then compare the 6 axes of the current position to the set position. If they are the same, then set the robot for position 4, and set a bit C13 that indicates the robot movement to position 4. Now position 4 will have different sets of coordinates for each of the boxes. When in step 2 and the robot has been set for position 4, then compare the 6 axes of the current position to the set positions. If they are the same, then set the robot for position 5. Reset the robot picker and set a bit C14 that indicates the robot movement to position 5. When in step 2 and the robot has been set for position 5, then compare the 6 axes of the current position to the next position. If they are the same, then reset the robot positions bits C10 to C14 and turn on the step bit done. This then moves on to our next step in our sequence. The program then will repeat for step 3 and step 4 for boxes 2 and 3. Logically, these are identical. Let's look at step 5, our load box 4 onto the pallet. Once we enter step 5 and the pallet and box is in position, we will set the robot coordinates for position 1. We will then set a bit to indicate that this step has been executed, C10. When in step 5 and the robot has been set for position 1, then compare the 6 axes of the current position to the set positions. If they are the same, then set position 2 for the robot and set a bit C11 that indicates the robot movement. When in step 5 the robot has been set for position 2, then compare the 6 axes of the current position to the set positions. If they are the same, then set the robot picker, set position 3, and set bit C12 that indicates the robot movement to position 3. When in step 5 and the robot has been set for position 3, then compare the 6 axes of the current position to the set position. If they are the same, then the robot for position 4 and set a bit C13 that indicates the robot movement to position 4. Now again, position 4 has different sets of coordinates for each of these boxes. When in step 5 and the robot has been set for position 4, then compare the 6 axes of the current position to the set position. So we know the box now has been put onto the top of the pallet. If they are the same, then the robot for position 5 then reset the robot picker and set a bit C14 that indicates the robot movement to position 5. When in position 5 the robot has been set for position 5, then compare the 6 axes of the current position to the set position. If they are the same, then the robot is set for the home position. Set bit C15 to indicate the robot movement to the home position. When in step 5 the robot has been set for home position, then compare the 6 axes of the current position to the set positions. If they are the same, then reset the robot position bit C10 to C15 and turn on the step done bit. This then resets our sequencer drum back to the start. Our ladder logic program is complete. Download this to the Click PLC with the Click PLC programming software and ensure the PLC is in run mode. Step 5. Test the program. We will use Modbus TCP on our Click PLC to communicate with the EasyPLC machine simulator. Call up the Robot Loader machine in start mode. The status of the machine simulator will be at the bottom of the screen. Currently we have no PLC connected. Select I/O drivers in the middle bottom of the screen. The EasyPLC driver is selected by default. Under the driver pull-down menu, select Modbus driver. This driver will communicate Modbus TCP, Ethernet, and Modbus RTU serial. Select the Configure button. We can now enter our Modbus driver. Select TCP IP. This means the Ethernet port on the computer will communicate with the PLC. The digital inputs from MS to the Click PLC will be C101 to C105. This will start at address 16484 due to the offset of 1. Digital outputs from the MS to the Click PLC will be C101 to C205. This will begin at address 16494 due to the offset of 1. We are indicating 32 digital inputs and outputs. This is fine because it's more than the EasyPLC machine simulator will require. Analog inputs from MS to the Click PLC will be DS1 to DS6. This will start at address 0 due to the offset of 1. Analog output MS to Click PLC will be DS101 to DS106. This will begin at address 100 due to the offset of 1. Select the OK button. You will now see the inputs and outputs specified for our Modbus driver. You can manually assign the driver outputs to the PLC inputs and the driver inputs to the PLC outputs. However, the automatic assignment works well and will save you time. Select Automatic Assignment from the driver option in the main menu. This will automatically assign the PLC I/O to the machine simulator I/O. Select Start Driver and exit the main menu. On the bottom left of the window, you will now see the driver communicates to the PLC with a green light. Select View I/O to know the input and output status of the machine simulator. Ensure that the PLC is in run mode. We can now test and operate our EasyPLC Robot Loader machine. Move around this virtual environment while you are testing the program. Using the data view window of our Click PLC programming software, you can now watch the inputs and outputs operate. If your program works correctly, it's time to move on. If not, you'll need to debug. Monitoring and viewing what is happening in the logic is critical. Looking back on the program steps, you might have to change your logical sequence, program, and then test again. This is all part of the process. When using EasyPLC, debugging is quickly done with no damage to any equipment. You may modify your logic several times before you get everything right. To learn more about developing logic, check out our tutorials on the 5 steps to PLC program development. You can practice your modification and debug by modifying the robot loader operation in the following way. Add a control panel with the start-stop buttons. Add an emergency stop condition that will trigger if the robot is moving and the light curtains are tripped. An additional reset button on the control panel will then have to be selected before starting the machine again. Calculate the rate of full pallets coming out of the robot loader machine in pallets per hour. Let me know how you made out in the comments below. If you enjoyed this video, please hit the like button below. If you have any questions about this video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want to get our free ebooks on numbering systems or bus data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.